Okay, here's a problem. How much energy does it take to boil 120 grams of ice from negative 14 degrees C? So say you're a mountaineer or something and you want to make yourself a cup of tea, or you camp by the seashore, lots of ice and snow around, and you want to turn that into a cup of tea. You throw 120 grams of ice into your belly. How much energy does it take to actually boil that water? And let's say how much energy does it take to boil it dry? So draw a picture. Here's my block of ice. Woohoo! Let's put a Bunsen burner on it. Put some heat on it. Right down. So mass is equal to 0.12 kg. Okay. What we have here, remember this drawing we had before, we had temperature versus energy. So if this is negative 14, we heat the ice up until it gets to 0. So this is going to be degrees C. Then it melts. Then it heats up, heating, and then it boils. Okay. How much energy is that going to take? So let's break this down into 4 bits. We're going to do this bit first, heating up the ice. Second is melting the ice. 3 is heating up the water, and then 4 is boiling the water to dry. So how much energy is Q1 is going to equal the mass of the ice times the specific heat of water times the change in temperature, which is equal to the mass is 0.12 kg. Specific heat is, we look that up, and for ice that's 2.108 kilojoules per kg per K times change in temperature 0 minus negative 14. See? So 0.12 times 2.108 kilojoules times 14 equals 3.54 kilojoules. Okay, so it takes a little bit of energy to actually, so it takes 3.54 kilojoules to bring this up to the freezing point of water. Q1 equals 3.54 kilojoules. Okay, for Q2, this is the melting, Q2, which is melting. Q2 is going to equal, it's going to equal the latent heat of fusion of the water times the mass, which is equal to, well, we look up the latent fusion, it's 334 kilojoules per kilogram. Multiply that by the number of kilograms, 0.12 kg equals 0.12 equals 40.08 kilojoules. And as you can see here, so Q2 equals 40.08 kilojoules. As you can see here, the amount of energy that it takes to melt the water is quite a lot compared to how much it took to bring it up. So in stage 3 we're going to heat it. So Q3 equals, again we're going to use, this is the temp one when we're changing the temperature. This is the one that we use when we're actually changing the state. This is the one when we change this. So changing heat, Q equals MC change T. changing state, Q equals L times mass. That's it. Okay, so let's go back up to here. This is going to equal M, which is 0.12 kgs, times the specific heat for water, which is 4.186 kilojoules per kg per K, times the change in temperature, so it's going to be 100 degrees C minus 0 degrees C, so we're taking it up to the boiling point of water, equals, again, calculated time, 0.12 times 4.186 100 equals 50.23 kilojoules. So Q3, the amount of water that it takes to boil energy, is 50.23. So it's not a lot, it's only about 25% more than the energy it took to melt the water in the first place. And then the last bit is the boiling, the energy that we use to boil. And boiling is a change in state, so we're going to use that equation there. So Q4 is equal to the latent heat of vaporization, because we're boiling it, times the mass, which is equal to, and then we look up the latent heat of vaporization, and that is a huge number, 2265 kilojoules per kg times 0.12 kg equals 2265 times 0.12 equals 271.8 kilojoules. So Q4 is equal to 271.8 kilojoules. That is why steam is so bad when you get scalded by it. If you get hit with boiling water, it's got like 50 kilojoules per kilogram of water, energy. If you get hit by steam, it's got 271 kilojoules of energy per kilo. And when that hits your skin, that has to go somewhere, and that goes into you. That's why steam is so nasty when it burns and scalds. Anyway, that's a side issue. How much energy did it take to heat up the water? Well, it took, so the total energy heating is 3.5 to bring the ice up to melting point, plus 40.08 to melt the ice, plus 50.23 to bring the water up to boiling point, plus 271.8 to boil it dry. So it took Q total, to boil how much water dry, it took 365.8 kilojoules of energy. Is that a little or a lot? That's a, yeah, well that's 1.2.4. What's that? Equals, it's about 2.5 minutes. If you were to plug that kettle or whatever into your wall socket, that kilowatt jug, that'll take about 6 minutes to do that. So it's a bit of energy. So anyway, the way that we do these is we work out each individual part, we figure out how much it takes to heat up the ice, how much it takes to heat up the water. If we then boil the water, how much it takes to, or heat it up steam, how much it takes. And then we take these melting points. So the question, let's just put in a second question. How much energy would you need to take out of this system to take the steam, 120 grams of steam, and boil it, take it down to -14? The answer is exactly the same amount.